Okay, everybody, sorry we're starting this a little later than expected. And we are talking about incremental language development. Oh, look at that. Number point to automatic merged to 12.2. Well,
Well, that's a question. Do we want it in 12.1?
I think it'd be wonderful to have it in 12.1. Let me look at what it does. And have we talked to Brett about this? Is Brett here by any chance?
He's not.
Can we see if we can get him?
Yeah, I can give him a call.
So it effectively removes the point in, when there is no decimal after it.
I think this is very good.
And the defaults?
Thinking. For sure, percent form to automatic.
Yes, it was already doing this.
I think scientific form, it should be automatic as well. Wait a minute, what do you mean it was already doing it? It was doing it in a hacky way by actually explicitly setting the number point to null string or something in percent form?
Well, you requested it does this, so it was doing it always. It was not possible to undo it.
I see.
Is that correct, Danny? Danny?
Not here.
Sorry, my screen froze on me and I had to get off for a moment. What was the question?
We were discussing number point automatic in percent form. It was always doing this, right?
Yes.
Okay.
Stephen, that was something you explicitly
No, it was
requested.
very good. It's very good.
Okay.
Look, here's a case that, okay, I believe 3 point times 10 to the 7 is never desirable.
Well, I'm thinking of some scientific situation in which you want to stress that that's all the information you have, but it's still not exact.
Yeah, but the fact is, we don't do 3 times 10 to the 7 for exact numbers, ever. You can't ever get that. If you have an exact number, there's no way to turn it into scientific notation.
What will scientific form do with an exact number if you want to just test it real fast?
Yeah, right. Splaff. Nothing, which is probably wrong. I mean, that probably should come back as 3 times 10 to the 11. I don't see why it wouldn't.
Well, exact numbers like integers and fractions and rationals do not do anything under any of the...
Yeah, I don't think we want to be changing that.
Fine. Okay, but then I'm making the claim that 3 times 10 to the 11 never wants to be 3 times 10 to the 11.
So you want all of these to default to automatic?
No, just scientific form.
No, scientific notation. I think that's ugly. I just don't think anybody would ever write that. And I don't think it's necessary, because by the time you're saying 3 times 10 to the 11, you know it's an inexact thing. What do other people think? I mean, this feels to me like a lot of the aroundism that you did, which I think has worked beautifully. So, let's use around-like thinking, so to speak, on the case of number points. Well, that's my suggestion, is that we remove the number point in that case by default. So, I mean, in a sense, that's a number point arrow, something even more than automatic, right? Because that's a number point, there's different specifications then for the scientific notation version versus the, I mean, what does ordinary number form do? What does ordinary number form do if I say 5 digits? Does it go to scientific notation or what?
Yes.
At some point.
We had an option to control the thresholds.
I see. So we've got that. Well, that default doesn't horrify me that much, actually. 3 point.
No, I don't see any reason why we would want to change what n does in terms of formatting.
Well, it's not n, it's fault. I mean, it's just... Okay, I think this is a higher order issue, but I think right now, if I do this, well, I can't do it here, but if I do this with with version 12, and I say number point arrow automatic, then I will just get 3 times 10 to the 11 there, correct?
Yeah,
Yes.
should. I'm sorry, with number form, yes.
Yes.
Yeah,
That's
yeah,
right.
you will.
So I would suggest we keep it as it is, and then we
Fine.
start seeing if users use number point automatic in scientific form.
Fine. Brian on our live stream is saying doesn't leave a decimal point to indicate the number of significant digits. Not really, unfortunately. 3 point doesn't really tell you very much, other than that it's an inexact number. And the whole point is that we're having an option to not put the point. Did we manage to find Brett here?
No, I was unable to get a hold of him, but I sent him an email, so maybe he'll pop in.
Okay. So can we tell Brett that we would like to use number point to automatic by default for tick labels? Okay.
Not also for 12.1, right?
Who knows?
I mean, that seems like a...
All right. Okay. Whatever. I think he's got a scheme that's very much like this for tick labels anyway.
Yes, I did discuss a bit with him the other day, and he mentioned that in most cases, it does already do this.
Right. So, I mean, I'm just saying, let's formalize that and just say this is how it's doing it. Because I agree, it does do this in most cases.
Right. So perhaps it's more a matter of finding examples of cases in which it doesn't work.
Right. Or just formalizing this is what it's doing so that you could switch it off if you wanted to.
Oh, I see. Yeah.
Right. Just say number point, just have a number point option that flows right into all the graphics, into the tick specifications.
Right.
Okay, looking good. Okay, now, what happened? Okay, so Jonathan's predicate logic stuff, is that in here now?
Yes, indeed, and that's why we need to review a couple of notes.
Okay, great. Well, are there examples? I hope there are examples of the predicate
there are
logic.
examples there. Yeah. Yes.
Okay. Do I need the very latest version or not?
No, this hasn't changed. Well, we changed it yesterday. I was working with Jonathan on this.
Okay. Yeah, let me just. Somebody is asking for external evaluators. I am going to show you an external evaluator. I think maybe I'm going to show you an external evaluator. I don't know if I am. Come on. Oh, that's a. Up, there we go. Ta-da! A Julia external evaluator. Anybody know how to type anything into Julia? Do you think I even have an installation? Splaffle. Somebody might ask Roger to install this, so I have this. That wasn't a very good demo. Could Devin, could you ask Roger to install this, please?
Yeah.
Along with the other ones that are in this list.
Sure. Yeah, let me screenshot.
Oh, okay, there you go.
Thank you.
Okay. Well, so sorry I can't demo it, but the good news is it's there. Okay, find equational proof.
So the first node was changed, and we kept the original so that you can compare.
What the heck? Oh, did I type the wrong thing?
Right. So excluded is the original, and now we have the new there. So I tried to explain better.
If find equational proof succeeds in deriving the theorem THM from the axioms, then it returns a proof object expression. If it succeeds in showing the theorem cannot be derived, it returns a failure object.
So we wanted to explain what reduction meant.
I think this is good. I like what you've done.
And then the three possibilities, because that was another frequent question. What I mean, in which cases? What happens if it cannot show either of them?
Right. Well, it's undecidable. Sorry, guys.
Right.
And undecidability turns into time constraint.
And then the next node addresses the new way of expressing things.
Which one here?
The one you are pointing at right now. Axioms and theorems.
Who cares that they're converted into equational form? Do you see it?
Well, if you look at the proof itself, you may see things converted into things that were not equations are equated to tautologies.
Okay, I see.
So that's why the very first line in the definition box says find an equational proof. So now we don't say equational theorem, we just say equational proof, because now the theorem can be general.
Do we really want to say logic theorem? I mean, it's not really logic.
No. Should be understood. We can remove it, yeah.
I think theorem of the symbolic theorem THM using the axioms, something like that.
Sounds good.
What do we mean by first order form?
It means that you cannot have.
It means you've got there exist. Do you have exists? Do you have not exists?
Well, what this means is that you cannot nest two
quantifiers
that one is
yeah,
quantifying
right.
over the other one.
Can be given an equational form or in general first order form paren with a single level. General first order form with a comma with a single level of quantifier.
Well, the quantifiers can be nested. They have to be independent.
I see. With a okay, or in general first order form with a single level of dependent quantifier or something, without okay, or in first order form, first order logic form can be given in equational form or in general first order logic form.
Yeah.
In first order logic form, dependent quantifiers cannot be nested.
What about equational form or as a formula in first order logic, like rearranging the words somehow a little bit?
Yeah, okay.
As a formula in first
order
logic.
I like that. I like that. It's better construction. Or as a formula, or wait a minute, can be given in equational form or as formulas in first order logic. So what specifically can we do in first order logic?
Well, we don't have to have always equations now, and we can use things like implies.
Well, then let's list what we can use. Can be given an equational form or as formulas in first order logic, and can contain Okay, so then in equational form can be any logical conjunction of blah.
Mhm.
In first order logic form, they can be any logical conjunction of blah, right?
Yes.
Okay, so what's the blah? So let's put that in. Oh, I mean, why are we even listing this? I mean, why don't we just list them all together? Who cares whether you can mix and match, can't you?
Yes.
Okay.
Yes. So the idea is that those that are not equations will be converted into equations. And
I understand. I understand. Can we give it an equation or as formulas in first order logic? Something like everything is processed as equations.
Yeah.
Formulas in first order logic. Well, formulas in first order logic are converted to equational form, to an equational form. Is that reasonable?
Mhm. Yep.
Okay, so now statements can be any logical conjunction of logical conjunction. Is that right? Ands, no ors.
Does it have to be conjunctions?
Well, the basic form is a list or a conjunction of statements.
Okay, any logical conjunction of. Okay, so what other things can you have in there?
So we can have, I mean, any of our Boolean operators implies, equivalent, etc.
Okay, so equational logic.
And or XOR.
Okay, equational logic. Okay, so this universal quantifiers over equational logic identities. But so what is the general form that we support now?
Yeah, so the third basic example is an example in which we don't have an equation.
You know, we really should put these in lowercase since we don't yet have mortal as a built-in function.
Okay. Yes.
Maybe we will one day have it as a built-in function, but we don't yet.
Yeah, you're right.
Okay, so let's take a look at what this looks like. Because we got to say somewhere that predicates are written as arbitrary symbolic functions. Right?
Mhm. Yep.
So, I mean, this thing here, let's take a look at whether we can prove that Socrates is mortal. That's pretty nice. I mean, the fact that it takes 53 steps to prove that Socrates is mortal is a bit disappointing.
Yes, that's because it goes through all these conversion steps.
Okay. Could we make that simpler?
Well, Jonathan says that Wallmeister has some sort of non-determinacy inside, and sometimes this number is smaller, but I don't think we have a way of controlling.
I see. Okay, anyway, let's look at what this looks like. Okay. Tries to find an equational proof of the symbolic theorem. Okay, I'm going to remove these because
yeah, of course.
I don't think that should be hyphenated. It's not an adjectival form. Okay, so now let's try and write down what they can be. So explain again what you can actually put in there. Because you don't need the equals here. You just need a predicate here. The statements can be any logical conjunction or logical anything of these things.
I think maybe we should say it should be a conjunction of terms and then explain what the terms can look like, right?
Okay.
And I think at the top
can be any
level,
logical conjunction of terms of the form.
Mm-hmm. So then it's somewhat recursive. You'd start with and of things and ors, and then you
Well,
can
let's
wrap that
get
in any
some
number
meat
of for
first. Let's
alls
get
and
some meat.
exists.
Let's get meat first. Equational logic identities. Okay, so then we've got f of blank blank blank, which is a predicate, right?
Yep.
Correct?
Yep.
Arbitrary symbolic predicate. Arbitrary symbolic predicate. Where do we say here that the operators, I mean, you can have any operator you want. And I don't think it makes that very clear.
What do you mean by any operator?
Well, I mean that the form of the LHS can be any symbolic expression.
Yes. Yes. We can have group theory things, products, etc.
Right. So this is completely unclear from what's said here. Totally unclear. Something like this is completely unclear. So this isn't a predicate. What is this thing?
Well,
It's a predicate.
Okay, let's say terms can, okay. So
we have equation. An equation is working as the predicate. So equation can contain anything, but the object by itself cannot.
No, but okay, hold on. So the main point is that this is a predicate here.
Mm-hmm.
This is now a predicate, but let's call it P actually. Arbitrary symbolic predicate. Okay, so then what we got to say here, the expressions, let's call it okay. Wait a minute. I'm trying to explain how we say the LHS can be an arbitrary symbolic expression.
Mm-hmm. We could say the two sides of the equation can be arbitrary expressions.
Assertion of equality. That's what that really is. Okay, then we say, now, okay, so what's the next thing we can say? Can we say logical combination? Is it true? Or is it just...
I think in that case it means conjunction.
No. Does it have to be a conjunction?
Yeah, so the way this works following Waldmeister is that it takes a list of statements and it assumes a conjunction. So that's why we start by that. And then other operators and is also understood as a list of this basic conjunction.
Okay, what is or?
Or is transformed into some equational form. So all other logic combinators like XOR, NAND, NOT.
Okay, well, so we can say any logical combination. It's fine.
Yeah.
Okay, so now what else is it down here? Now we've got for all and there exists, right?
Yeah, so inside for all, we can have any of the previous.
Right, predicate. Assertion.
Expr.
Okay.
Not really expert. This has to be something that represents logic.
Yep.
Assertion that the predicate pred is true for all values of vars. Ugh.
Perhaps it should be a statement rather than predicate.
I agree.
So how should I? STMT, it's like Fortran. Okay. It's true for all values of ours. Okay, fine. Okay.
And the
Now what are the
the two previous cases are statements.
what?
The two previous cases are statements. So
Right.
predicate is a particular case. An equation is another case.
Right. Now what about there exists? Can we do that?
Yes, yes. But
Okay. Okay, now what do we say here? So then we say the expers the expressions exper I can contain arbitrary symbolic. The exper I can be arbitrary symbolic expressions. Formal operators or abstract operators are typically represented can be arbitrary symbolic expressions in which with heads representing, what do we call them? Formal, abstract, whatever. I'm looking at a few live stream comments. I'll get to some more later, but I noticed Carl saying that it would be good to have a tutorial or a background and context section for find equational proof. He's right.
mm-hmm. Yep.
Somebody feel like writing one? Like a tech note about it would be good.
Yes.
Can be arbitrary symbolic expressions with heads. How do we want to say this? With heads representing formal operators or something?
Yes.
What?
Operators or products. I think those are the two main cases.
Okay. The statements STMT can consist of arbitrary logical combinations of predicates.
Are we considering like mortal from that Socrates example to be an operator?
Not really. I'm thinking of it as a predicate.
So maybe we want to say like predicates, operators, or relations.
Let's remind ourselves in mathematical logic, this notion of a language, right? They have words for these. There are literals. There are, what are those things? Can you remind me what those are? Because we should just have a table that says how you do each of those things, right?
Right.
What are those things?
There's relation symbols. I don't know if those are handled by the prover though, Jose.
Yeah, they are handled. That's the whole point.
Okay,
Relation
so
symbols.
relation symbols, predicates. Do we have like just unary predicates?
Absolutely. Happy as a clam to have one of those.
Function symbols.
Right.
Function, relation, operator, predicate.
I mean, there are a lot of things which have, okay, representing formal operators, functions, products,
Etc. I
operators,
think
or
might be the
functions.
best thing.
Formal operators, functions, etc.
Yeah, and then maybe explain better in the like background section.
Which doesn't exist yet.
Right.
Okay. Okay.
Mhm.
Looks good. This isn't quite formatted right. This formatting needs to be fixed.
We'll take care of that.
I don't know whether I can make this work. All right. Oh my gosh. The answer is no, I cannot make it work. Okay. All right, this is looking great. Okay.
One small question is, Jonathan was saying that now that dataset can support colors in individual rows, etc., whether it's worth matching the colors of the proof graph.
Oh, interesting idea. Ask design.
Okay.
That's a very big proof graph. Let's just make it a little bit smaller. Yeah, why not if we can?
Perhaps just in the header on the left.
Yeah, why not? But very light coloring.
Right.
Okay, cool.
Okay, so that's about final question approved. And now something we have discussed by email is the connection between axiomatic theory and finite group data.
Yep.
So I have this suggestion, which is we could make axiomatic theory return the group axioms together with the relations.
I think that'd be very cool. Very cool.
And this could be passed directly to find the question approved.
Very, very cool, in my opinion.
And this is very nice. I prefer to have it in axiomatic theory rather than finite group data, because then it can follow directly the notation of specification of product, identity, etc.
Right.
Which is the last input.
Okay, so hold on. The defining relations here. Oh, I see. You can then give this.
Right. So that those A, B represent the 10 and 4, which are the generators in the notation of finite group data. So finite group data goes for readability. So it's very clear to read it, but not very useful. Well, in axiomatic theory, we have to express the products in non-associative.
What can I prove about the tetrahedral group from this?
So, for example, you can express other elements and prove other relations, like the product of E times D times D is equals to D times E times something else.
So if I want to just reduce a word in the tetrahedral group, for instance, how would I do that with this?
Well,
I mean, yeah, go ahead.
This depends on Wolfram, and we don't think that Wolfram can do that. So Wolfram can prove a given identity. So if you know the result, you can.
No, I understand that. I wonder if there's a way that we could figure out. I mean, I think this is clearly simplification in an arbitrary axiomatic system is another interesting problem.
Yeah, indeed.
And I think it would be. I think somebody should look at this. I mean, I'm going to add this to my summer school list. I think that's a good. Just a minute here.
So this is an area in which, together with what we have with Wolfram, it would be good to have the Ted-Coxeter algorithm. And then with that,
yes,
we could do some non-trivial computations.
Right. What's involved in doing the Ted-Coxeter thing?
It's Coset enumeration. which
Okay.
is some sort of reduction, as you were talking about.
Okay. Okay.
So it's one of the fundamental algorithms for relations.
I mean, I wonder whether that's just an algorithm that we could at least get for the function repository to begin with, the Tog Coxeter thing.
It needs to be fast enough.
Yeah, okay, fair enough. Well,
It's probably one of those things that will be good to have in C.
except these days, I mean, Tom keeps on delivering compiler results. He just showed me one this morning. That was a thing that I wrote. He managed to make it 8 times faster, which I thought was kind of lame. But okay, well, this looks lovely. Okay, Cayley graph.
Yeah, that's another discussion. So what I'm going to suggest here is to follow the sequence of colors used by graphics, which is quite nice. So this is an example for that.
That's just fine. This is just ugly.
Yeah, totally. And so these are the first 2 colors in that sequence. Perhaps making it a bit thicker or something like that.
Yeah, I think that's okay. As okay.
And now this other way, I mean, I think you suggested this, a way of allowing easy specification of the color of a given generator.
Right. So I'm suggesting you put that into Cayley graph, and by the time it's in graph plot, it's not going to have. By the time it's in graph, it's going to have turned that into some kind of edge style specification, and it's no longer going to have.
Yeah. So before I had to specify the color of each individual edge, and you saw that long list. So here it will be a matter of specifying the generator as a permutation with its color.
I understand, but by the time it's a graph, you can't post-process it. If you want to post-process it, you're back to doing individual edge coloring.
Right. Yes.
That's fine. I mean, same thing with plot to graphics.
Right.
But I think, okay, can you slip this in ASAP, basically?
Yes, they should be.
Did we ask anybody whether there's a better choice of a better color map than this one? Because it might be that there's a slightly nicer one to use with the color schemes here. I mean, you're basically looking for an indexed color. I don't know. I mean, this looks okay to me. I don't know for sure. I mean, it would be good to just ask somebody in design if they have a good idea.
I haven't heard from Jeremy, but I will ask.
Well, I think Jeremy does not know what Cayley graphs are, and I don't blame him.
Okay, I will discuss with Brett.
This is okay. This is okay. This is probably going to be just fine. Because I mean, the point is in the Cayley graph, other than for the free group, right? We're going to have more than one color.
Exactly.
I mean, even
most important groups have only 2 or 3 generators, so it's not so many.
Yes, I understand. Have a little discussion with them. But this looks fine. If you can't come up with anything else, that looks just fine.
Okay. And then finally, I wanted to point out that the difference in options currently between Cayley graph and graph is just directed edges, because I always thought, obviously, the edges in a Cayley graph are directed. But I've seen sometimes people representing them without the arrow. So I was wondering whether to reinsert that option.
In Cayley graph. Why not?
Cayley graph.
Yeah, I don't see why not. I mean, I think it's not as useful probably, but it's not obviously ridiculous.
Do you ever get like different colors along between the same 2 vertices?
No. Wait a minute. Between, I see. But wait a minute. A generator, 2 vertices here. Can you get there by generator A as well as generator B? Is the question.
No, I mean, can you get from vertex 1 to vertex 2 via your first generator, but it's the second generator that goes back?
No, because it's a group. I mean, if we did these for semi-groups, yes, but for a group, right, it's the inverse. Isn't it? Am I confused? No. I'm confused. I'm totally confused. I'm totally confused. How are we representing inverse? So the inverse, okay, basic Cayley graphology.
Mhm.
Okay, this is a generator A, right? This is an order 2 generator, which is going back on the same. That's cycles 1, 2, and that's probably cycles 1, 2 as well. That's an order 2 object.
Right. So the answer is that this is not just a representation of the group. It's also a representation of the choice of generators for that group. So what Brett is saying is that imagine that you specify in the generators G and the inverse of G. Then you will have that situation. In this case, it happens that the G and inverse of G are the same, and that's why you have to add it. In general, it will not happen.
Wait a minute. So let's try a bigger example.
So think, for example, of the inverse of the blue generator.
Yes.
If we added, if this generating set was these two generators plus the inverse of the blue, we would have all cycles reversed with the
I see.
arrows in the opposite direction and the other color.
I see. So there's just a shadow Cayley graph. That's the whole thing turned backwards.
Right.
Which isn't very interesting when we don't show it.
Exactly. Once you add a generator, you never add it in the generating set the inverse.
Can you tell me something which has more than 2 generators?
Abelian group 222.
Come on, we can do better than 222. Okay. So this would presumably, this is a graph, right? So I can presumably say graph 3D of this. Okay. So we should check that the new specifier, I mean, these colors don't look as bad in 3D.
You get some
Brett-
shading going on, so it helps.
Brett, did these colors, if Jose is proposing to use the default colors from, I don't know, I'd prefer something a little bit jollier, perhaps.
Can you do color data of 97 color list?
Everybody likes the 97 one.
It's our default. It's what our defaults are based on. 2 arguments.
Okay.
But I took the first 2 colors precisely.
Yeah.
I know. I'm just saying.
So I'm asking, is there something a little bit jollier than that blue?
Right.
Do I look through the indexed colors here?
It's the same list.
No, I understand that.
The truth is that they look better in plot itself. So if you compare to plot, why is that?
Plot's thicker.
I see.
Well, maybe this should go thicker, but then what happens when you get a very dense Cayley graph? I think I'd be happy. Do we need to get Jeremy here? Let's see if we can get Jeremy just for a moment. Could
Sure.
somebody see?
I'll give him a call.
I haven't a clue what to do here. Can we experiment with? I haven't a clue.
I mean, okay. Now look at 98, which I think is jollier, or at least it's a
It
bit
is
darker.
jollier. It is jollier. Yeah. I think that's better. Can we try 98 here?
Yes, it's a matter of changing the C1 and C2. The colors there.
Okay. So it's basically C1 is, so if I just say C1 is color data 98 of 1, is that right?
That should be right.
And then you need to evaluate S4, which is the graph above. That one.
Okay, they need to go thicker.
Mm-hmm.
How do we do that?
Directive.
Yes.
C sub I. These C sub I's need to be directives.
Yep.
What would you recommend?
Thick is the easiest one, probably.
That seems a bit thick, but let's try this also for, let's try setting this. Let's just try S4 equals Cayley graph of like symmetric group of 6 elements or something. Just see something a little bit denser.
Stephen, I just joined too, and I sent you my notebook of what I was working on, which is pretty close to this.
Splaff, what happened here?
Well, these are the edges for S4. As we said before, we have to work on the edges individually at the moment.
Oh, I see. Horrifying. Okay, so that's not going to work. Okay, Jeremy, just a minute. Did you just send me an email? Yes.
Yeah, and there's some code to plug in colors a little easier. Yeah, I just didn't like the yellow in 97. It was a little too light, so I tweaked the colors a little bit, and a version of 97 with a little better colors.
Yeah.
And
I mean, that's completely doable. That's
partly there's some opacity, a little bit of opacity there, and it lightens every color that you give it. So you have to give it a little brighter and darker colors.
Are you happy with the node color here?
I lightened it. I didn't like the default node because it just felt like it was jumping out too much. You see really the node points. So I didn't feel like you needed a big blob there.
Let's talk group theory for a second. Do you want to see the node points or do you not want to see them? I don't think you want to see them particularly.
Do they have tooltips on them? Or are they?
There's a version where you can do that. Like if you scroll down, they're fine. That's
yeah, but the node there isn't.
So both the node and the edges are group elements. So that's why both have the tooltips.
Right, I see. So this is
Right.
you're
And this is
applying
basically
that
your
group element,
multiplication
you're getting
table.
that thing.
But in general, the important things are the edges, not the nodes for Cayley graphs.
yeah. The default a little bit of blue and it's darker, and they just stood out and and kind of detracted from everything else.
So do we think this is a?
This is better. Yeah, it's kind of neutral gray, and it doesn't. We don't need another color when we've got all this color going on.
Okay, so this is the more. Does it have default? Yes. Do I evaluate just random one of these?
Yeah, any of those should work. There's only so much you can do with a case like this that has so much going on. So it's thinner lines starts to help when it gets really dense.
I think it looks decent. Anybody else got comments on this? I mean, I think it's a lot better than it was before.
I think so. I think, especially when it starts to get busy, switching away from the directed edges would probably help a lot.
Okay, how do we feel about that? Seems okay. The green is losing it a bit. Boy, it's cool that you can just make a Cayley graph. Look at that. That's an abelian group. I can tell.
Those colors aren't as good for 3D. We might have to do something. They get dark at certain angles, right? Really dark with the tubes.
Well, also the green tubes look thinner than the other tubes. I don't know why. I think there's a difference in value with the green somehow.
No, I think they are thinner somehow for some reason.
Yeah, the green's really light looking compared to the orange, which I don't get.
All right, so that's an issue, but I think we're close here. I mean, the green could go a little bit more verdantly green, so to speak, perhaps, and then it might help in this case.
Mm-hmm.
Really cool that you can do this. Okay. All right, so do we think we have a solution here? We're close. You've got, Jose, you're going to have something to install in the next day or two, hopefully.
Yep.
Okay. Okay, and Brett, you had been involved with the number point discussion. We wanted you to be part of that. This is the new number point arrow automatic that doesn't put points after things.
Right. I mean, in general, the ticks don't.
Ethan on live stream is suggesting using the new shading primitive. I don't know which shading primitive we'd use. One of the toon shade. We just have lines here. We don't have enough. We don't have enough of a polygon to shade.
Yeah, I mean, those tubes are so narrow that anything you do is going to get lost.
Okay, let me just. I'm just going to look at some live stream things. We've got to wrap in a moment here. Carl is asking for syntax highlighting for external languages. We are well aware of that issue. That is sort of in flight, but it's complicated. And AST functionality, we're also aware of that. We've had some early projects, which actually we should see if we can get that project in the function repository. We have a project that makes ASTs for any. Could somebody find out if Chris Cooley's project for making ASTs for external languages could go in the function repository? That's a question for Devin to ask Todd. Yeah. Okay. Okay. Question is external language interface for R using R-Link. Anybody know the answer to that? I think the answer is yes, but I don't know for sure. Carl is asking for domain-specific languages. I don't know exactly what one means by that because you can respecify anything. If you want to change the syntax, that's a whole different can of worms. You know, everything that I did in SMP, I'll eventually redo in Wolfram language after a 35-year recovery period because it didn't work in SMP, of which syntax rewriting was one classic example of absolutely horrifying thing. It'd be nice to get back the proofs graph in NKS book style. Which that's an interesting suggestion. I have to remember which style we're talking about there. Hold on. Why isn't this going up? Weird. Oh, there we go. So the main proof in the NKS book is the one. Oh, you mean things like this? Oh, can of worms. Do you understand what this is, Jose?
Yeah, I think so. It's about
By the way,
working
Jeremy, why is it that when I press magnify here, it doesn't magnify this part of the...
It's magnifying the fonts and even the margins, but there's a constraint on how big that image is. It's trying to be a certain percentage of the page width of your browser width, right? And you can only get so big. So as it gets smaller because as the elements enlarge, the page is still constrained. And so we have this other solution that we're implementing.
Okay. Somebody sent in this idea for JavaScript to make these things pop out, which seemed like a really good idea. Anyway, okay, but so what this is this is indicating what the rewrite that's being done here is. You see what I'm saying?
Yes. I'm wondering whether, how would you express the critical pair lemmas, which have like two legs?
What are these? These are pure substitutions.
Right.
You say are only a part of the story.
Exactly, yes. Proof graph.
So you're saying substitutions are which ones?
So we have the lemmas in which there is a clear substitution.
Okay, there's a substitution lemma.
Right. And then
which in this case is using a number from the axiom list to say which substitution it is, and that's just applying the substitution.
Right.
Okay, that is a critical pair lemma. Why is this saying EL prover backtick cons 12?
Because we need a way to specify all these unifications, etc. And we never found a good way to express them.
Formal variables. Or at least variables, numbered variables. But the EL prover backtick is surely not the right answer.
Mm-hmm. Right.
By the way, for that documentation, can we please look up I remember that in textbooks of mathematical logic, there are things when you talk about a language for a logical system, there are things like constants and so on. That there are a bunch of terms that are used, but we should fix that. I mean, that's goofy. Okay, but you're saying the critical pair lemma depends on some other result here.
Yes, it's a way of combining two previous statements. You unify them, you get a new one.
Yeah, well, this isn't that. This is just pure substitution. I mean, I think I had another one here. This horrifying thing here.
So it may still be the case that we can get a substitution from the critical pair lemma, but where does it come from? I wouldn't know how to express.
Well, you know what? This is actually not a bad thing either. This is pretty nice. That's a lemma. That gray thing is a lemma. And then this is using lemma such and such, blah, there's the result. Using lemma such and such, blah, there's the result. So what that corresponds to in this diagram is not sure. There's a way of mapping this into that. We should look at that. It's a good suggestion. It's silly we hadn't looked at that before, because these things, I mean, considerable effort was put into making these things look decent. Okay. Page 810. Thank you. Is that what page I'm on? Yes. Okay, good. We're talking about the same thing. Can one specify the proof by hand to validate it if automated derivation fails? We don't have a good way. I mean, the representation of that proof, there is a symbolic representation of that proof, right? What is that symbolic representation?
Well, it's the internal form of proof object, which is very close to the proof notebook.
But isn't there a thing? Isn't what the called? Isn't what is the thing called?
It's proof function.
Proof function. Yes, but this is also a It's a subset of.
I think, look at those horrifying things.
Yes. This is what I was saying before. We need ways to express all the meaning here, like all this map. And it's unification. We don't have in the system functions that represents correctly the unification needed here.
We should talk about this. This is a separate topic. This is an interesting topic, but this is basically representing. This is representing patterns on both sides of an expression, in some sense.
Yes.
Yeah, we should.
It's taking two expressions, two substitution rules, and combining them to form another one.
Yeah. Okay. Suggestion about real-world examples pages. That's an interesting idea to do it that way. To just to take. That's a. Yeah, Devin, if you just put that in the documentation, that suggestion, and just add it to our documentation discussion.
Yeah, got it. It's a good idea.
Find equational conjectures analog for geo stuff. What does that mean? You mean a conjecture that says the area of, I don't understand what that could possibly mean.
It just meant an analog of fine geometric conjectures, but for equational proofs.
No, for geo stuff was the suggestion. For spherical trigonometry or something.
Yeah, spherical geometry rather than flat geometry.
Eventually. How are we doing on all the spherical distance and so on things? Did that project get underway? The geo stuff for a unit sphere type thing.
Yes, no, I haven't worked on that. At some point, we thought perhaps having those functions in the function repository.
Oh boy, I'm being told that it's in 8 minutes time, which is not right now, we'll hit 500 hours of live streaming these kinds of meetings. So I think it's time to wrap up, and we can start our next meeting by celebrating our 500-hour milestone. So we'll have to get to these another time. Great. Okay. Thanks all very much. Thanks to folks on the live stream. See you all soon.
Yep.